All right. One sample Z distribution for confidence intervals of means. This is scenario one. So a publishing company has just published a new college textbook. Before the company decides the price at which to sell the textbook, it wants to know the average price of the textbook in the market. The research company at the research department at the company took a random sample of 36. So we know that our sample is size 36 textbooks and collected information on the prices. The information produced a mean of 70.5. So from the sample, we got a 70.5. It is known that the standard deviation of the price of all textbooks is $4.50. So they said this is known. So this is the standard deviation of the population. This did not come from the sample. This is the standard deviation of the population. Then it says construct a 90% confidence interval for this type of textbook. So let's look back at what recipe says. It says define the parameter mu in context. I said we're going to start off let mu equal the true population mean. So number one, let mu equal the true population mean. Well, what are we interested in? Price of textbooks. Mean price of textbooks. That's our definition. Number two, we were supposed to do the conditions. And in this case, we're just going to say that they're assumed. In college, you may have to do them. If you're in AP statistics, you'd have to do them. Here, we're not as concerned about them. We will talk about them more later. But right now, we're not worried about it. Three, our formula. And our formula was X bar plus or minus Z star sigma divided by the square root of n. Now, I don't expect that you've memorized that yet. There it is, X bar plus or minus Z star, the standard deviation of the pop divided by the square root of n. Enter data if given. Hey, no data. That's good. So we don't have to worry about number 4. We're going to put no data. That was nice. We'll deal with data in our next video. Identify and label all of your inputs. So this was number 5. Number 5 says sigma equals 4.5. X bar equals 70.5. N is 36. Then we need to calculate Z star. All right, and calculating Z star bothers people. All right, well, first off, I need to identify my confidence level. And they said, hey, construct a 90% confidence level. So we're going to do 1 minus 0.9 divided by 2. So this is what we're going to put in the calculator, 1 minus 0.90 divided by 2. And here's where you do that. You're going to go to inverse norm, second vars, inverse norm, parenthesis, 1 minus 0.90, close parenthesis, divided by 2. Our mean is not mean because we're calculating a Z star. Because we're calculating a Z star, mean is 0, standard deviation of 1. In case you forget, it's posted right there on the directions. All right, remember, we're making a cake. And we get negative 1.6448. But I said, use the positive value, so we're just going to make it positive. So Z star equals 1.6448. Number 7, plug in the values. So if I'm plugging in the values, I'm going to have X bar 70.5 because I'm plugging into this equation. 70.5 plus or minus the Z star that we just got, 6448, times our standard deviation was 4.5 divided by the square root of 36. Part 8 says calculate the interval. All right, so part 8 says calculate the interval. So stat, arrow over to test. We're going to look for a Z interval, which happens to be number 7. My standard deviation, oh, it was 4.5. My X bar, we got 70.5. They told us that from the problem. My sample was size 36. And my confidence level, they wanted us to use a 0.90 confidence level. And I go to calculate that, and I'm just going to write that down as it shows up. This is my interval, 69.266 and 71.734. Now, what we just did here, and I'm going to draw a picture, even though it wasn't on the directions to do so, is we centered this on X bar. This area right here is 0.90, and we calculated a lower bound of 69.2 and an upper bound of 71.7. And what we're saying is 90% chance that the true population mean lies somewhere between these two values. So the next thing is to write the conclusion. All right, so number 9 is to write the conclusion. And so we are 90% confident that, and as soon as I get to that, I'm going to just copy this right down the way I have it, that the true population mean price of textbooks lies within the interval. And what was our interval? Oh, 69.266 to 71.734. So basically, we think this textbook is going to cost somewhere between $69.26 to $71.73. That's what we think it's going to cost, or that's what we think the market bears. And we're 90% confident that it's going to be somewhere in there. Now, the fact of the matter is, there's a 10% chance that we're wrong. Okay, there's a 10% chance we're going to be wrong. Now, they didn't ask us to explain the confidence level, but we're going to go ahead and do this, even though they didn't ask us to. All right, so in repeated sampling, we expect, and so far I'm just copying straight off the template, that this method will capture and now I'm going to restate what I have here, the true population mean price of textbooks. %90 of the time. In other words, what we're saying is our method is so incredibly awesome, it's so fabulous, that it will work 90% of the time. All right? That we're 90% of the time, our method is awesome and it works at 90% of the time. Okay, so the next thing, use the above problem to calculate a 95% confidence level for the same textbook. So basically, we have X bar plus or minus Z star sigma divided by the root of n. Well, our X bar is still going to be 70.5 plus or minus. I'm going to leave a space for Z star because I don't know that off the top of my head. I know my standard deviation is 4.5, and I know I need to take the square root of 36. So in this case, let's calculate our Z star. Second quick, second vars, inverse norm, clear, parenthesis 1 minus 0.95 close parenthesis, divided by 2. Mean of 0, standard deviation 1. And we get z star of 1.9599. Now that's what we had on the previous page, so we could have just copied it from the previous page. Then we can go stat test number 7, and we're just going to change our confidence level to 0.95. So this means my interval is now 69.03 to 71.97. If I notice, the 69.03 is a little bit lower than this, and this value is this 71.9 is a little bit higher than this. So this is wider than the 90. All right, this is wider than the 90%. So we're going to go back and do the same thing again. So x bar plus or minus z star sigma divided by the root of n, 70.50, because we know that. We'll come back and figure our z star in a moment. And this is going to be 4.50, and this is going to be the root of 36. We didn't change that, but we did change our z star to 99. So second bars, inverse norm, clear, parenthesis 1 minus 0.99, close parenthesis, divided by 2. And I end up getting 2.5758. Remember, we just want to write down the positive. Now you can write down the negative, but it's just more confusing, so don't do it, all right? So we're going to go back and go stat test number 7, z interval, and change this to 0.99. And I end up getting 68.568. Hey, that's lower than this. And then I have 72.432. And this is larger than this. So this is wider than 95%. So when we look, what do you notice about the 3 different confidence intervals? The intervals get wider as our confidence increases. So the bigger the confidence level, the wider the interval. All right, if everything else is the same, the bigger the confidence interval, the higher the confidence level, the bigger the interval. All right, so the interval gets bigger as the confidence level increases. All right, that concludes this video.